determine what amino acid each nucleotide triplet is going to code for, right? But unfortunately, for a code, it is a one-to-one correspondence. One word means one phrase, or one phrase means one word. Unfortunately, because of biology, certain other things like prokaryotes won't exactly code for an amino acid for the same triplet. Like, for example, in eukaryotes, AAA will code for lysine, right? But in other things, it may not be lysine. And GAU for aspartate, I think in prokaryotes, I don't remember what it coded for, but they don't code for the exact same thing. So you can't say that the three letters are a one-to-one correspondence, because it depends on what codon chart you're using for different species. Prokaryote will have a little bit different, especially for the start and stop codon. For methionine, it's the start codon, which it tells where to start the transcription. That is different from species as well. Next slide. Why isn't a triplet a code? Because some people say that the three letters is a code. Well, no, that's more of a cipher, because again, it's representing individual letters to represent one particular amino acid. The RNA codon chart is degenerate, and again, I don't know why I called it the RNA codon chart. Scratch that. It's the codon chart is degenerate, meaning that more than one triplet can encode for amino acid. Because again, third base wobble. There's a redundancy in it, and with a code, you can't have redundancy. You have to have a one-to-one correspondence to have a code, because if you have a code book, then you need to know what word is representing, or what phrase is representing something else. And if you have multiple possibilities, then you're not communicating to the person you're trying to communicate the code to what your message is. So it has to be one-to-one. So in that regards, because it's not universal, it cannot be a code. Here we go. So yeah, so I knew I found it somewhere. It's AA in humans codes for lysine, but in other species like starfish, it'll code for asparagine. So that is not a one-to-one correspondence in echinoderms. Next. Almost done. I want to touch a little bit on Shannon information, only for the fact that I think this is going to be where John's coming from. He's going to be coming from communication theory, and Shannon was the one that kind of came along and said, okay, what does it mean to have information in a system based upon the entropy of the system? So the way it works is this, in a very succinct nutshell. Log base 2n is the minimum number of bits to carry the information of DNA. When there's 4 possible nucleotides, it would take log base 2 of 4, which, if you do the math, is equal to 2 bits of information. That'll cover all possible states, okay? If you have 0, 0, each one of those is 1 bit each, so you have 2 bits. That'll represent like T, 0, 1A, 1, 0, C, and 1, 1G. So for the 4 possible states, you only need 2 bits of information, because those 0, 0, 0, 1, 0, 0 can represent all 4 of those, okay? So that's what Shannon information kind of basically is. Next. A little more simpler, a quarter can have 2 possible states, heads or tails, assuming fair coin and outcome, meaning that the coin is weighted properly and it won't land on the edge, and you have to have an outcome of one or the other, probability of 1. In this particular case, the minimum bits to describe the possibilities is log base 2, which is 1 bit. 0 for heads, 1 for tails. It only requires 1 bit to do that. Next. Shannon information and entropy. I was going to remove this because I thought it was kind of too much for this particular discussion, but since in here, the minimum amount of information in bits to effectively communicate a signal or message via a noisy channel due to entropy. What that basically meant is that if I have a channel where you're not getting 100% efficiency, what is the minimum amount of bits that I need to communicate a signal from the sender to the receiver? And that's based upon a very well-known formula for entropy, WK log M. In this particular case, is just a modification of log omega, where omega is the microstates of the system. But if you ever look into thermodynamics, that formula is ubiquitous. It's a very, very common formula in entropy. Next. Or entropy. But what Shannon did is he took the entropy and he made it a formalization for it, which is that formula there. I'm not going to get into specifics of this. The only reason I brought it up is that when you apply it to DNA, it's based upon the index there of I as an element of A, C, G, and T, meaning that Shannon information is contingent upon those symbols. Again, information and code are not exactly the same thing. The information in the system is not the code. The code is C, and G. or ACGT. Next. Things that the DNA doesn't code for. Not all DNA codes for protein, right? So when you're talking about DNA, there are other things that it will make. It'll make tRNA, or what's called non-coding RNA, which is transcribed but is not ever translated into proteins. The exons, if you look at RNA, it'll have introns and exons, and the pre-RNA gets spliced when it takes all those introns out, and it's just left with the exons. Yeah, I had that backwards, by the way. That was another mistake that I made that I wanted to correct. It keeps the exons, it splices out the introns. Also, it doesn't code for protein folding, which is a very critical part of how proteins work. They have to be shaped exactly right to work. The DNA sequence has no bearing on how that protein is going to be folding. It's based on conformational changes due to charges from the amino acid residues, it's called. It has no effect on gene expression. So these things that are incorporated into the system have nothing to do with the code, but they all go into how proteins are made. Next. Also, the code doesn't code for epigenetic factors, histone acetylation, deacetylation modification, which is basically a fancy way of saying how much DNA is going to be exposed to that RNA polymerase. Those little protein things, those little round things, DNA goes around those. And if it's really tightly wrapped, the RNA polymerase can't get to it. Right, it has to be kind of loosely wrapped, and if they're really close together, the polymerase can't get in between them. So what histone modification does is kind of separate those histones, allowing the RNA polymerase to reach the DNA easier. That's not coded. That's not quote unquote coded by those sequences in the DNA. Next. Additional thoughts on DNA not being a code. And I think this is a real big one. Codes require portability from one medium to another. DNA contains information, but nothing that can be detached and transferred to some other medium, like raised bumps, such as Braille or magnetic tape. So if I said, I want to take the code off DNA, it's not portable. It doesn't translate into Braille, because the Braille, all that can represent is the A, D, C, and G, which is the code. This is the same problem you have with Morse code. Morse code is not a code. Morse code is a cipher. This is the same thing with binary. Binary is not a true code in that regard. Matter of fact, if you actually go look at Morse code, they actually call it Morse cipher in a lot of places, because it is more technically a cipher than a code. What is transferred to RNA and proteins by means of the central dogma of biology is merely chemical and physical structure, by which the laws of chemistry by psychochemical conformational changes. So what that basically implies is that the only thing that's really being ported over from the DNA to the protein is how to put those amino acids together, right, to form the protein. There's no code in that actual system. There's no code in there, information. Next.
Okay, can I just ask a quick question here?
This is my last one, by the way. Yeah, go ahead.
If binary code's not a code and Morse code's not a code, then what are some examples of code, according to you?
Having a code book, for example.
Like, for example, you can have a code book. You can have a code book for binary code. Yeah, I mean, there's code.
We'll get in. Let me finish up.
Okay.
But yeah, Morse code is technically more correct than cipher.
John, you're going to get your turn. I thought I was going to have to let's see, but John.
This is so good.
At the end, you guys will get a chance to go back and forth. Let's finish this presentation. Steve.
Okay. So I think what it boils down to.
John, behave yourself.
I think the word code is used differently in different things. I've looked in information theory. I've looked at signal processing. I have worked a little bit with discrete signal processing, and the term code is not utilized that way in that. Computer programming is used completely different. It's used as a program language. Language is not a code. I know a lot of people argue language is code, but everything I've looked at from linguistically, it's not a code. Again, the symbology would be that you have a secondary set of symbols representing a primary symbol. Language is not a one-on-one correspondence. It cannot be a code. But again, biology, law, like even in the terminology of a legal system, a code is by actions we were supposed to abide by, right? You have a legal code. That's not a code by which I think John would agree that we're talking about. So even in biology, legal, cryptography, the word code has multiple different meanings. I'm arguing from the most strictest, which is called sensu strictissimo position that DNA is not a code. Sensu lato, which is a very broad definition, people can call it a code, but I still think it's much more of an analogy than a true code. And I just want to end with Dave. I sent you a something that I can't screen share. Can you do it real quick?
And while he's waiting on that, let me make an announcement real quick to you guys. If you watched the show last night, where we had the guy that came on to talk about the 1080 poison that's going on in New Zealand, if you remember, in the middle of the interview, or when we were kind of wrapping up, his wife broke into the interview and said that the police were at the door and they had come to take his guns and his gun license. So we had to cut it abruptly short. Well, he actually continued to film and sent me the video of his confrontation with the police. So we'll be uploading that to the channel tomorrow, and you'll be able to see the police come in searching for the guns and how that unfolded. So be sure to check that out tomorrow morning on the channel.
Crazy.
Yeah, it's wild. Okay, go ahead.
And I just put the link in for some other things, like where it says Morse code is not a code. It says, despite its name, Morse code is not a code, but a cipher. But I did want to leave with Francis Crick, who one of the discoverers of the triple helix of DNA. He said this. He said, and this is from Who Wrote the Book of Life, a story of genetic code. In fact, years later, Crick granted, quote, the proper technical term for such a translation rule, strictly speaking, not a code, but a cipher, in the same way that Morse code should be really called Morse cipher. I did not know this at the time, which was fortunate because, quote, genetic code sounds a lot more intriguing than, quote, genetic cipher. And that is from the one that actually won a Nobel Prize for determining the structure of DNA. So even he grants it is much more like a cipher than a code. And if people want to go look up Morse code is more like a cipher, they're more than welcome to. I put the link in the video in the live chat, and there you go. Floor's yours.
All right.
A bit longer than I expected.
Thank you, Steve.
And I was talking fast. It's a lot of stuff to go over.
It's John's turn now. So, all right. So we have a little hashtag war going on Twitter. Don't forget to @NonSecShow. So we have hashtag Team Steve and hashtag Team John. So now it is going to be John's turn. I'm just saying.
All right.
I'm hashtag Team John. All right. So Dave, do you mind putting up John's presentation?
Thank you. So I've got a lot of spots in here for questions, and I'm happy to have Steve ask questions during that time, or people who are writing in to ask questions during that time. So if we get super chats or whatever, I've got lots of spots in this for that. But so again, the question that I was really hoping we were going to ask here is the genetic code a real code? Because as Steve and I both agree, DNA itself is not. It's just a molecule that the code is written in. This little box here on the screen, this codon chart, this is the set of rules that govern the genetic code. And if we can go to the next slide here, we'll get a quote from good old Richard Dawkins. He wrote a book called A River Out of Eden. And in this, he says, after Watson and Crick, we know that genes themselves, within their minute internal structure, are long strings of pure digital information. What is more, they are truly digital in the full and strong sense of computers and compact disks, not in the weak sense of the nervous system. The genetic code is not a binary code, as in computers, nor an 8-level code, as in some telephone systems, but a quaternary code with 4 symbols. The machine code of the genes is uncannily computer-like. Apart from differences in jargon, the pages of a molecular biology journal might be interchanged with those of a computer engineering journal. So, according to code, people who study computers, things like binary code, the genetic code is a real code. And if we go to the next slide, this here is the reason that there are so many people today, I think, that are upset calling the genetic code a real code. And it's because there is this argument that comes from creationists. It says that the genetic code is a real code. All codes that we know of were intelligently designed. Binary code was, for example. Morse code was, for example. Therefore, they conclude the genetic